Eighth graders, Mr. Moran here. We got our first do now for 921. Take a moment and take a look at each equation. I know you worked with equations when you're in seventh grade. I just want to know what value or values make each equation true or makes each equation true. It looks like I missed an S in there. First of many mistakes you will find. So because this is a video recording, pause me. I want to keep going just to keep the video short and not too much space. So what values make each equation true? Well, if we read the first equation, it's 2 times a number equals 8. So what can I put in for n that makes it true? And I'm sure many of you would have said 4, and I'd say why, and you would say 2 times 4 equals 8. Great. Okay, how about the next one? Can you think of a number that you could put in for x, or n in this case, that will make this true? Can you think of any number? Right? And so I might say, anyone got a number? And someone might say 1. Okay, does 1 work? How do you know? Well, 2 times 1 equals 2 times 1. I'd be like, great, awesome. Anything else besides that 1 works? 1 can make it true. Anyone have another number? And we might say 2 works. And I'd be like, oh, cool, why does 2 work? Well, 2 times 2 equals 2 times 2. And I'm like, great. So we got 2 answers. Now the question is, are there more than 1 and 2? Does anything else work? Right? Someone might say 3 works. 2 times 3 equals 2 times 3. And I'm like, great, 3 does work. Are we done? Did we list all the values that make this equation true yet? We've got these 3. Are there more? And at this point, we would say, like, yeah, there's a lot more. Everyone said, like, everything will work. Because 2 times anything will equal 2 times anything. Well, I would ask you, does negative number works? Could n equal negative 1? And we could check, does 2 times negative 1 equal 2 times negative 1? The answer is yes. Okay. Do fractions work? Can we put a fraction in? For example, 1/2. Does 2 times 1/2 equals 2 times 1/2? Well, of course, right? And we might even find, if we put like a square root, like the square root of 25, does that make it true? Well, yeah, because that's 5, and 2 times the square root of 25, which is 5, is 10. Yeah. So we can say that n has, well, can we list all the solutions? No. So in this case, we're going to say, what values make this true? We're going to say all real numbers. And I'm sure your teachers last year talked a little bit about it. But when we say every number, we think everything can work, we say all real numbers, because we don't want to say everything works. There are things that aren't real. You'll talk about in 10th grade. But for now, we're going to say using all real numbers. Great. Okay, and how about this one? Can you think of a number that makes, or a value for x that makes the last one true? What plus 2 equals what plus 3? And someone always says 0. They're like, oh, cool, 0 works, because 0 plus 2 equals 0 plus 3. No, that's not going to work. Okay, so 0 doesn't work. Anyone have another number? What plus 2 equals what plus 3? What can we put in? And you might be saying to yourself, I don't know. And some students often raise their hands and says that, like, there is no value, right? There is no solution to this problem. There's no number that makes this true, right? And then I would ask usually, well, negative numbers, no negative number works. And someone who's really good might say, nope, negative number works. And I might be, why? Why is there no number for x that makes this true? Can't put a single number in here. And someone often says, if you have something and you add 2 to it, it will never equal that thing plus 3, right? 1 plus 2 will never equal 1 plus 3. Or 2 plus 2 will never equal 2 plus 3. Or 5 plus 2 will never equal 5 plus 3, because this side will always be 1 more than this side. So there's no solution, right? And so last year, your teachers would have talked to you about that equations, at least the ones you've studied so far, have a couple options. We can have one number that makes it true. We can have all real numbers make it true. So all the numbers you know at this point. And then sometimes there's no solution. There's no numbers that make this true. Cool. So you would have gotten, if you can take out your homework, supplies, and homework. That's what I would have said if we were in person. But for now, take your homework out, or you've sent it to me at this point. So we're gonna get into our notes. So maybe you copied this, made a copy of this already, or you want to just add it to your notes. This is our first section we're going to study in our algebra book. It's 1.2/1.3. We're going to be solving some equations today. And we're going to solve equations using our operations of, addition, subtraction, multiplication, and division. Cool. You don't have to write this question down, but you might have it. The question is what is an equation? What is an equation? And what does it mean to solve an equation, right? And people say, for example, why is this an equation? Right? Why is 2x equals 15 an equation? And the simple thing is, an equation has an equal sign. That's it. Anything that has an equal sign, you can think of it as an equation. Okay? And the question that you did spend time last year on, it's been a little while, is what does it mean when you solve an equation? For example, 2x equals 15. Does anyone know how to solve it? How do we solve it? And someone often says, by doing things to both sides, right? So divide both sides by 2, which I would be like, that's great. So 7.5. Right? So what is 7.5? If we solved for x and we got 7.5, what does that tell us? What are we doing when we solve an equation? And it's early in the year, so everyone always pauses and doesn't really answer. Someone, though, reaches back to the do now, and they realize it's finding the values that make each equation true. Yeah, that's it. So what does it mean to solve an equation? It means to find the value, or values, right, that make an equation true. That's what it means to solve an equation. It means to find the values or value that makes an equation true. So if we take 2x equals 15, we can see that 7.5 is the solution because 2 times 7.5 is 15. We found the number that makes it true. We were just doing that, right? Okay. And someone remember that we can do things to both sides of an equation. So let's solve these. We're kind of just getting warmed up. We have an equation, and we want to solve it, in this case for k. So we want to find out what value of k makes this true. 6 equals what plus 8? And I always like to throw it out there. Did anyone be able to figure it out in your head? 6 equals what plus 8? And so a lot of people end up realizing that it's a -2. And I'm like, great, -2. Yep, -2 plus 8 equals 6. But maybe, hopefully, Miss Connors or Mr. Alexander pushed you and said, well, there's a way to algebraically get the solution. Like someone up here recommended dividing both sides by 2. And that's what we're going to focus on, right? We're going to just practice everything. So we're going to undo to get k by itself. And someone probably mentioned it earlier as well. So k over here plus 8 equals 6. So what we're going to do today is solve equations algebraically. And I like to put a line down the middle. And we're going to do things to both sides. So we're going to take away 8 from both sides. And because 8, if we take away 8 from this side, 8 minus 8 is 0. And some of you say when we solve equations, we're trying to get the variable by itself. And there we go. We know k by itself. And then we do 6 minus 8 is -2. And that's what someone told us earlier. So it's great. So -2 plus 8 is 6. Awesome. Okay. So today we're either going to add, subtract, multiply, or divide to get equations. It's our first kind of lesson rethinking about solving equations. So we want to solve this for x, find out what makes this true. And I guess you could guess, negative 3/4 plus what equals 5/7? It's tricky. Maybe on purpose, right? Well, we have a negative 3/4 plus x. So what would I need to do to undo this negative 3/4 so we're just left with an x on this side? How would we make this cancel it out, undo it, so it becomes 0? And so someone said, well, it's negative 3/4, so we'll add 3/4. Right? Negative 3/4 plus 3/4, 0. And then we just have to add 3/4 to this side. Okay? So now, what's 5/7 plus 3/4? And you might remember you can add fractions. They just have to have a common denominator. You can turn 4 and 7 into 28. Nope. Don't tell me right now. I'm teaching. Can you stay down here, please? I'm teaching right now. It's live. I'm recording. So my kids who watch this is what's going to happen. And this is what's going to happen as I try to teach this whole year. So you guys have to resolve yourself or just get away from each other until I'm done. I can't. All right. Sorry about that, class. I have kids at home. I'm sure you're struggling with it as well. So, great. And there we go. We got it. 41/28 is our answer. And that'd be kind of hard to do it in our heads. But if we add 3/4 to both sides, because negative 3/4 plus 3/4 is 0. And then we remember our rules about adding fractions. Boom, we got it. Okay. All right, there's 2 more examples, and then we're going to practice a little bit. And then, because I want to get your minds working, it's been a while since you've probably been doing some math. So read this. I often ask students, say, 3x equals 4.2. That's what people say. But it's really 3 times x equals 4.2. So how are we going to get x by itself? How are we going to undo this times 3, right, to get x by itself? Well, since it's multiplication, how do we undo multiplication? We have to divide both sides by 3. 3 divided by 3, they cancel each other out. And we get x equals, we just need to know 4.8 divided by 3. 1.6. So 3 times 1.6 is 4.8. And you could always, how do we know if we're right? We would just check our answers, right? Boom, we got it. All right, so we added to undo, we subtracted, we multiplied. This one's always tricky for students. Okay, someone read it. So we got negative 4 equals x over negative 5. That's how usually students read it. But what does this fraction bar really mean, right? It's not, you can say it as x over negative 5, but you could also say it's x divided by negative 5, right? So what divided by negative 5 is negative 4? And you might be able to do it in your head, but I want to practice and I want to see you do this for homework. I want to see you doing stuff to both sides to get x by itself or the variable. Find the solution. So, how do we undo division? We need to use multiplication. Negative 5 times negative 4 is 20. And then we get x, we multiply these together. We get x times negative 5, which is negative 5x. And negative 5 times 1 is negative 5. Shoot. We didn't get x by itself, did we? Unless Mr. Marion is supposed to just do this. Yeah, but why do we get to do that, right? Because -5 divided by -5 is 1, right? Which we often skip out. So it's 1x. So 20 equals 1x. And you probably may have learned that we simplify the 1 out because 1 times anything is itself. So there we go. We found that it's 20. And 20 divided by -5 is -4. So that is how just want to put that note down. So we're going to multiply by -5 to cancel out divide by -5. Sweet. So if you were in class live, you would be taking a moment or two to just solve each equation, show your work by doing math to both sides of the equations. That two, it looks another typo, to both sides of the equation. All right, so this is a good time to pause, do stuff to both sides of the equation, and then you can come see my answer. So pause now. Okay, so because I'm just talking to myself, I see that x is being added by 12. So if I undo a positive 12 and get it down, so this cancels to 0, do that. So I get x equals, this is a great chance to talk about, we have -15 minus 12. What's -15 minus 12? And what I would have talked about is that there's actually no such thing as subtraction, right? So what I do to help students is that minusing 12 is the same thing as adding -12. So we have -15 plus -12. So we get x equals -27. Boom. Okay? And we can check. -27 plus 12. There's 12 positives. -27 negatives. We'll be left with -15 negatives. 15 negatives. All right, we have 30 equals 4 times x. So to cancel out, we're going to undo that times 4. Right, there's our variable, and we'll divide both sides by 4. And we get 30 over 4 equals x. Sweet. Done. Boom. Oh, unless, can we simplify this a little bit more? 30 over 4. Well, yeah, we could reduce the fraction, right? That's, divide them both by 2, you get 15 over 2. Boom, found it. So is this fraction simplified now? Are we good? The answer is yes. You don't have to rate it as 7.5. We're going to do a lot with this. It's cool. Leave it as a fraction. As long as your fraction is simplified, you're good. And this is 99% right, right? 30 over 4 is totally right. It is the answer. It's just not simplified. 15 over 2. All right, C. It says 14 equals -12 plus what? Okay. Here's x. It's adding -12, right? So how are we going to undo that -12? And we can also think of a negative subtraction, right? So how are we going to undo this -12? Well, if you add the opposite to it, so add 12, cancel out. So we get 26 equals x, and there's our solution. 26 plus this is that. All right, and then our last one, which you probably got already. Did anyone get an answer? -20 perchance, maybe? Well, let's see. What divided by 5 equals -4? Well, x is being divided by 5, so it makes sense that we undo the division using the opposite operation, which is 5. You would get 5x over 5 equals -20, and these cancel, so we get -20, someone probably said. Sweet. Okay, I want to give you some time to, is that it? Yes, okay. So your homework tonight is to go to page 20. Oh, sorry guys. seeing that. That's terrible. Okay. Go to these pages and solve each of the equations, okay? If you have printed up this document, you can see the answers are there. So I'm going to state it right now. If you don't show your steps when you submit your homework, you will get a 0 for homework, okay? All the answers are here. It's just a way for you to check your answers, but what I want you to do is to show me what you do to both sides. What'd you do to both sides of the equation to get the variable, or to get the by itself, or like to get the answer, the solution, okay? So solve each equation, find the value that makes it true. We'll come and talk about it tomorrow, making sure to answer any questions that we have. Okay, so that is the first lesson.